Over the past few years, a group of medications originally developed for diabetes has moved straight into the center of the fat loss conversation. They're prescribed in clinics, they're discussed online, and they're often presented as a major turning point in weight management. Naturally, the same questions keep coming up. Are these drugs the definitive solution to obesity? Do they finally allow fat loss without constant hunger? What happens to the metabolism over time? And what happens when someone stops using them? This video isn't about hype, and it isn't about judgment. It's about understanding how these drugs actually work, how this technology evolved, what it can realistically deliver, and where its limits still are. If you watch until the end, you'll be able to evaluate these medications with much more clarity and much less noise. Why these drugs exist in the first place. To understand GLP-1 drugs, it helps to start with the problem they were designed to solve. Type 2 diabetes is not just a blood sugar problem. It's a signaling problem between the gut, the pancreas, and the brain. Years ago, researchers noticed something interesting. When glucose is eaten, insulin release is higher than when the same glucose is delivered directly into the bloodstream. This difference became known as the incretin effect. It showed that the gut is not passive. It actively communicates with the brain about energy intake. GLP-1 is one of the hormones involved in that communication. What GLP-1 actually is. GLP-1 stands for glucagon-like peptide 1. It's a hormone released in the intestine after food intake, and it affects more than one system. GLP-1 increases insulin release when glucose is present. It suppresses glucagon. It slows gastric emptying, and it sends satiety signals to the brain, especially to areas involved in appetite regulation. One point is important here. GLP-1 is a signaling hormone. It does not burn fat. It does not raise metabolic rate. It does not increase calorie expenditure. Its role is to influence how much we eat and how driven we feel to eat. Natural GLP-1 doesn't last long in the body. It's broken down within minutes. That makes it unsuitable as a medication. The breakthrough came when researchers developed GLP-1 receptor agonists that resist rapid degradation. Early versions required frequent dosing and had limited potency. Over time, longer-acting molecules were developed. This evolution eventually led to once-weekly injections like semaglutide. Semaglutide is a selective GLP-1 receptor agonist. In real life, its most noticeable effect is appetite suppression. People often report feeling full sooner. Portion sizes naturally decrease. Food becomes less dominant in their thoughts. Reward-driven eating tends to quiet down. Fat loss happens because total energy intake drops, usually without conscious calorie counting. Nothing about semaglutide directly increases fat burning. Weight loss is the downstream result of sustained lower intake over time. Tirzepatide takes this concept a step further. It doesn't target only GLP-1 receptors. It also activates GIP receptors. GIP plays a role in insulin sensitivity and in how the brain responds to food signals. The combined activation seems to reduce food drive more strongly and more consistently. That's why average weight loss is often greater with tirzepatide. Not because it burns more fat, but because it reduces intake with less internal resistance. Even with these medications, some things remain the same. Basal metabolic rate does not increase. Adaptive thermogenesis still happens as body weight goes down. Muscle loss can still occur if protein intake and resistance training are inadequate. These drugs lower appetite pressure. They do not remove the body's long-term energy conservation mechanisms. Responses vary widely between individuals. Several factors play a role. Dieting history, degree of metabolic adaptation, muscle mass, sex and hormonal environment, stress and sleep quality. Someone with a heavily suppressed metabolism may still plateau even with strong appetite control. That explains why results can look dramatic for some and more modest for others. This is one of the most important questions, and one of the least discussed, honestly. When GLP-1 drugs are discontinued, appetite signaling gradually returns. Food noise often comes back. Energy expenditure does not stay elevated. If no structural changes were made during treatment, like rebuilding muscle or improving metabolic flexibility, weight regain becomes likely. The drug creates a window. What happens inside that window determines what happens after. Retatrutide represents the next generation. It targets 3 pathways at once: GLP-1, GIP, and glucagon. Glucagon signaling may influence energy expenditure more directly. Early results are impressive, but this drug is still experimental. Long-term safety and sustainability are not fully known. Promising does not mean proven. Risks and long-term considerations. Potential concerns include gastrointestinal side effects, loss of lean mass when nutrition and training are poorly managed, micronutrient deficiencies from chronically low intake, and psychological reliance on pharmacological appetite suppression. These are powerful tools, and powerful tools require context. GLP-1-based therapies have changed how appetite regulation can be approached. They don't override physiology. They don't eliminate adaptation. They don't replace intelligent training and nutrition. What they do offer is reduced friction. The future of fat loss is likely smarter timing, better personalization, and clearer expectations. Understanding the mechanism matters more than believing the promise. And this is body logic.